Welcome to the multivariable calculus section. In this section we'll be discussing curl and divergence. So we've already seen the relationship between Green's theorem and line integrals. A large portion of the remaining topics are revolved around different mechanisms to compute line integrals. A vast majority of these mechanisms utilize curl and divergence, which are two new topics of discussion. So first we'll discuss curl. So curl is the div, or the del modifier, cross the f vector. So essentially what we're doing with the curl is stating that we want to take the partials of every single component and we want to take the cross product of that from our vector function. And so we get curl of f is equal to ijk, partial x, partial y, partial z, P, Q, and R, which results in this very large mess, essentially. So it's important to note, though, that the curl of a vector provides us with unique information. So if the function fxyz is continuous, that means that the curl of the delta f is equal to 0. And additionally, if f is a conservative vector, that means that the curl of f is equal to 0. And more so, the curl of f is defined on all three components or axes in order to have continuous first order partial derivatives. And curl f, then, f is a conservative vector. So the curl of f is utilized throughout the entirety of multivariable calculus, and it is actually a pretty important concept, but the divergence of f is nonetheless important. So the divergence of f is very, very simplistic. It is just the del modifier dot f, and all we're doing here is taking the partial of x of p, the partial of y of q, and the partial of z of r, and that's literally it. So if we had 2x squared plus 2y squared plus 2z squared, and that was our f of x of y of z. If we said find the divergence of f, we'd just say okay, 4x plus 4y plus 4z. And that's literally as simple as it goes. While the curl is a little bit more difficult, the divergence is a lot of it simpler. I hope that helps you understand curl and divergence a little bit more. That is it for the video. Thank you.